We have a phosphorus. Excuse me. Once again, we only have one phosphorus there. The first element labeled in the naming process does not have to have mono attached to it. All right. So we have phosphorus. Well, we have 5 chlorines. We already know that chloride, IDE, is the anion name for chlorine, but we have to attach the prefix penta to our chloride. So we get penta chloride. Next, we have 4 phosphorus. So phosphorus is going to remain the same, right? We don't change that to phosphide because it is first in our naming process. But we do have to attach the tetra, the 4. We have 4 phosphorus, so tetraphosphorus, and we have 6 oxygen, which if we look up is hexa. Now we're going to go hex oxide. Now we dropped the A, right, because of this bad boy right here, not O. All right, hex oxide is goofy to say, so we just drop that A, hex oxide. All right, let's go down here. We have sulfur and we have fluorine. Okay, so once again, 1 sulfur. We do not need mono. Sulfur. Sulfur hexafluoride. Okay, move down. Once again, we're using sulfur. Sulfur trioxide. Well, once again, the only thing that changes is now down here we have 2 oxygen instead of 3. So we have sulfur dioxide. Last but not least, oh man, we've got 2 nitrogen. So let's go ahead and label that dinitrogen. Remember, there's no change to nitrogen because it's coming first. All right, we're just adding the the 2 root or prefix to that. And now we go with our oxygen. We have 3. That is a tri. An oxide is the anion name. Trioxide. Review the rules. Review your prefixes. All right, make sure you are clear on these bad boys. You will use them constantly. All right, we will refer to them, and if you don't understand them, it's going to be a challenge not only on the test but further down the line in this class. So here we're going to test your knowledge. All right. The difference between type 1, type 2, and type 3 binary compounds. What you are going to do is once I'm done giving instructions, you're going to pause and you are going to identify the compounds as either type 1, type 2, or type 3, and you're going to give me the name of the compound. All right, understand? Go ahead, pause it, do your work. Okay, so I am assuming you have done your work. How I'm going to format this is I am going to do binary compound section here, and I am going to do my name here. You can format it however you want, but this is how I'm doing it because it makes sense to me. All right, so NaCl, binary compound. Well, I see sodium. I know that's a metal, so I'm either a type 1 or a type 2. Sodium has a +1 charge, so I know that it only has a only has a +1 charge, therefore it is not a type 2, it is a type 1. The name? Sodium. Well, the anion name for chlorine is chloride. 1 for 1. Alright, let's go with PCl5. Well, phosphorus. Yes, it is on the right side of the staircase. That's a nonmetal. Chlorine, another nonmetal. Alright, so I am dealing with a type 3. Type 3 binary compound. Beautiful. Well, what are we going to do? Well, I know that's phosphorus. So let's go ahead and write we know that there's one phosphorus. I don't add mono to the beginning or the first element. Chlorine, well, I know it's chloride. I have it right above. So what do? I attach the root. I attach penta, the prefix, excuse me, not the root, the prefix to chlorine, and I have pentachloride. Now I will not be this mean. I won't even make you name it right here. Okay? But I do have 4 phosphorus bound together. Well, simple. We know that phosphorus from above is a nonmetal. Well, I only have 4 phosphorus together. So do you see a metal in there? Well, you shouldn't. Okay? So we have our type 3. Okay, type 3. We need to have this as a type 3. Okay. Next, we've got nickel and we have oxygen. Well, I know that nickel is a metal, but I look, it's in the transition metals. Okay. Well, now I know that we're dealing with a type 2 binary compound. So let's go ahead and write our 2 there. Remember when we're naming this nickel, I need to have parentheses. I know that oxygen is oxide. Okay, but what charge do I assign to Ni2O3? Well, how'd we get there? We had nickel with a +3 charge, and then oxygen with a -2 charge. Right, we're going to go ahead and do our crisscross method. And does in fact give us what is stated up above. Okay, so we know that nickel has to have a +3 charge, so nickel 3. Last but not least, we have beryllium iodide. All right, beryllium, metal, iodine, non-metal. Okay, good news about beryllium, it is a type 1. All right, it always has a +2 charge. So let's go ahead and write it. And we have, all right, once again, don't worry about this yet. We don't need you naming this, getting confused. Okay. Just know that that is a type 3. That is a covalent bond, a molecular bond. So let's go with some more things you should know by now. All right, what you will be held responsible for on this test. Okay, we take a look at cations. We should know these are metals. We should know that they are positive. Okay, but why are they positive? All right, let's take a look at sodium. You know what? We've used sodium a lot. Let's take a look at lithium. Lithium in your periodic table will have atomic number 3 and an atomic mass of 7. Okay. Well, yes, it is a cation. But what we should be able to see is we have 3 protons and 3 electrons. Okay? Remember, if it's on the periodic table, we assume that it's neutral. But it forms a cation. In fact, it forms a positive cation. But why? Okay. Take a look, and we have lithium with one little electron floating around its outer shell, that valence electron. Okay? It is much easier for lithium to go ahead and give this electron away to, say, something like chlorine. That has 7 electrons. It's looking to gain 1. It doesn't want to give away 7. Okay, it's like us. Alright, the reason fast food's so popular is it's easy. Well, it's easier for chlorine to just take 1 electron than it is to give away all 7. Similarly, lithium, it is easier to give away that 1 valence electron than gain 7 more electrons. Alright? So, lithium has the affinity to give away that electron. Alright? We're going to say that lithium went and gave its electron here to chlorine. Chlorine is now a very happy customer. It has the full octet, that noble gas configuration, in its valence shell. Lithium, in fact, is happy. Why? Because from here, that's not a smiley face, that's an arrow. Lithium now only has 2 electrons. Let me get that so you can see it a little better. Electron, electron. But remember, that's in its first outer shell. So 2 is the most it can have. It is happy. Alright? From here, we can see that if we lose this electron right here, that electron is gone. Well, we had 3 protons. Sorry, trying to get a different color. We had 3 protons and 3 electrons. It gives away 1 electron, and now that negative charge is passed on to chlorine. So chlorine has a negative charge. Lithium now has the positive charge. That is where this Li+, this cation, comes from. So let's take a look at polyatomic ions. All right. When we are putting these together, there are a few rules and common mistakes that happen. All right. So let's start with ammonium. All right, ammonium is NH4. Okay. It has a +1 charge. What this is saying is there is a nitrogen, and it has 4 hydrogens attached to it. Alright, so this is one singular compound. Okay, remember, one singular compound. So don't go spreading it around and you will see what I mean. In fact, you may have made some of these mistakes. Okay. We are going to combine ammonium, upset stomach joke, ammonium, and let's put that together with, say, a sulfate. Which is SO4 and has a -2 charge, or 2- charge. As we put these together, right, we see